So this is question number 21 from 2020 CSIR Mathematical Science paper. So what the question says that En be a sequence of subset of R, the real space, and we have defined this limit n tends to infinity supremum and infimum of this En. We have to find which of the following statements is true. Okay. So let's take this. First of all, let's understand how this union and intersection is coming. So, if we consider this, let us consider this En as a sequence of zeros and ones. So, you can write it as 0, 1, 0, 1 in this manner. So, it can be written as E1, E2, E3. Now, coming to the first, our supremum in En, that limit n tends to infinity intersection k to 1 infinity. So limit n tends to infinity, supremum of En we can write it as this intersection k1 equal to infinity and union n equal to k to infinity e of n. It is given, right? So if we take the value of k as for k equal to 1, k equal to 2, k equal to 3, so how the sequence will look like? So for k equal to 1, if we put this in manner this, so it will be summation. Now supremum of En, look at this. So this supremum of En is nothing but the union of from n to k equal to this n equal to k to infinity to En. Whenever we put this limit over here, n tends to infinity, so this intersection comes into the play, that it is from k to 1 to infinity. So supremum of En, if we write it, we can write it union of this n equal to k to infinity En, and when we put this limit, so it will place the intersection in this from k equal to 1 to infinity. So for k equal to 1 in this supremum, it will be union of n equal to 1 to infinity En. So this n equal to 1 we put over here, so k equal to, it will be look the same, 1, 0, 1. Okay, if we put for k equal to 2, so we'll replace the first one, 1, we'll start with 1, 0, we'll go like this. For k equal to 3, we'll go to this, it will start from this 0, so 0, 1, 0, 1, it will go like this. Okay, so limit of n tends to infinity, supremum of En, whatever the expression we have given, so it can be written as union n equal to 1 to infinity En intersection union n equal to 2 to infinity intersection union n equal to 3 to infinity en, and it will go like this. So we will have ultimately the 0 and 1, these two sequence will be there. So this is for the limit of supremum of n, and we have given the infimum also, the limit n tends to infinity, infimum en k equal to 1 to infinity in intersection n equal to k to infinity en. So in the case of infimum, first we have this infimum of en is the intersection of n to k to infinity en, and whenever we will put this limit n tends to infinity, so this union will come into play, this k to 1 to infinity. So in the supremum of n, we can decompose this into this manner, the union and the intersection. So similarly for the infimum, if we put k equal to 1, so what will be the sequence? So it will be n equal to 1 to infinity en, 0, intersection 1, intersection 0, intersection 1. So it will be nothing but a 5. For similarly for k equal to 2, k equal to 2, it will be the same for this n equal to 2 to infinity en, right? So if we put the limit n tends to infinity, that is this infimum of n, infimum of en, so it will be coming as union of k equal to 1 to infinity, and this term is not only nothing but this 5, so it will be the limit of n to infinity, it is coming as 5. So in our first option, it is saying that both are equal, so the first is not the correct option. So we have checked which, so it is given the which of the following statements is true. So the first one is wrong, so let's check with the option 2. So it is given that limit of n tends to infinity supremum en, x is belongs to this particular sequence for some n. Okay, so we can write in this option number 2, limit n tends to infinity supremum of en is x belongs to the union n1 to infinity en. So we can write it in the similar manner, x belongs to a sequence ej where x is not belongs to ei and I is not equal to j. Okay, without the loss of generality, if we assume that x only belongs to e1 and for the other does not belongs to any other set e1 e2 e3, so you can write it in this manner, and this x is belongs to e1 and x does not belong to the E2 union of E3 union of E4 and so on, right? But according to the this limit of supremum, we write in the same manner, this limit of n tends to infinity, supremum of En, it is nothing but that E1 union of E2 union of E3 union up to this intersection E2 union U3 union, so it can be written in the same manner, right? So it is nothing but that X belongs to E2 union E3 union E4. From this we can get, right? So this our assumption is wrong. So this is not the correct assumption. So we can say that option 2 is not also the correct option. So let's check with the option 3 and 4. It is given the infimum of En, X belongs to this En for all but finitely many n, and the last option is for infinitely many n. Okay, this is option 3. So we have the X belongs to the limit n tends to infinity, infimum of infimum En. So you can write it as some k to 1 to infinity intersection n equal to k to infinity En. So we can also write this as X belongs to this intersection of n equal to k to infinity En for some k. So X, we can write this X belongs to Ek intersection of Ek plus 1 intersection Ek plus 2 for some k. So this X belongs to E1, this Ek. X belongs to Ek plus 1, X belongs to Ek plus 2, right? So we can write this that X is E of n for all let's write it over here. So X will be belongs to this E of n for all n greater than equal to k, right? So in this case our option is the option 3 is the right one, correct option. And let's check with the option 4. So if we consider that so if X belongs to the Em where M is an odd number and Ex does not belong to the Ek where k is even, if we assume this even number, okay, yes, it's an even number, so X will does not belong to E2, so we can write it X does not belong to this E1 intersection E2 intersection E3, and X will also not belong to E2 intersection E3 intersection this, right? For the odd this even number, the X will also belong to the E4, which states that X is not a part of the E3 intersection E4. So we can write that X doesn't belong to this limit n tends to infinity infimum of En, right? That is, X belongs to En for infinitely many n, right? But X does not belong to the limit n tends to infinity infimum of n, which is also a contradiction we are getting, this infimum of n. So our option 4 is also not the correct option. So here case only the option 3 is the right option for this question number 20.